Hey, let me give a brief tutorial here as to how you might want to do this to find the position. So let's read what it says here. It says a ball is rolled up a hill with an initial velocity of 36 meters per second, slows to a stop, and rolls back down in 6 seconds. So we have our 0 to 6 seconds here. It says the initial velocity is 36. Now, if it rolls up to a hill and back down, well, we know that if it's 6 seconds total, then 3 seconds will be up at the top of the hill, and we know that as it rolls up, it slows to a stop, and then speeds up on the way back down. So we got to get from 36 to 0 in 3 seconds, so that's going to be a change of negative 12 each second. So 24, 12, 0. But we know this change is constant, so decrease by 12, 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 and decrease by 12. And that actually makes a lot of sense, because if the speed was 36 on the way up, it's 36 on the way down, just in the other direction. So let's put this in here. 1, 2, 3, 4, 5, 6 seconds. So we have 36, 24, and 12, negative 12, negative 24, and negative 36. So those are the 2 points I started with, but 1 is 24, 2 is 12, 3 is 0, 4 is negative 12, 5 is negative 24, and 6 is negative 36. So there's our graph. Now, we also want to be able to figure out what the positions are, right? So we have 1, 2, 3, 4, 5, 6 seconds. Okay? So how are we going to do that? Well, the thing that we know is that the area is equal to the change in the position. So I'm going to find the area of this rectangle, and I'm going to find the area of this triangle, and we're going to go from there. So this area of this rectangle right here. So area of the rectangle is equal to base times height. The base is 1. The height is 24. So that's equal to 24. Now what about this little triangle here? The base of the triangle is 1/2 base times height. The base is 1, the height is 12, because the difference between 24 and 36 here is 12. One half of 1 times 12 is 6. So the total area of 24 plus 6 is 30. Now it starts at 0, so we'll put that in there. Okay? All right. Let's try this again. Okay, we're going to go with the Okay, let's do the next one. So now what we're going to do is this time I have a rectangle there, and this time my triangle is here. So you can see the triangle is bigger. So the area of a rectangle is still base times height. The base of this rectangle is 2, and the height is 12 for 24. And this triangle, well, the base is 2, the height is 24. 1/2 2 times 24 is 24. So the total area, 24 and 24, is 48. Okay, so let's do 3 seconds now. What's interesting about this one is that it's only a large triangle. So there's no rectangle on this one. So this is 1/2 the base. You can see the base is 3 seconds. Oh, sorry, that was a... The height is 36. 1/2 of 3 times 36, 3 times 36 is 108, half of that is 54. Now, what's interesting now is that the next area that I have to draw is here. And if I shade that area, we can see that this triangle here the base is again 1 this time. You see it's just 1 wide. And the height is -12. So 1/2 of 1 times -12 is -6. So my total area is this big one, which is 54, plus this -6. 54 plus -6 is 48. And if you're paying attention, you might notice, oh, well, there's a 48 over here. So if this is 54 at the top and these are both 48, I wonder if this one's 30. Let's look. I'm going to drop this down here. And what I see is I have a large triangle. Actually, it's a medium-sized triangle. One half the base is 2. The height is -24. That's -24. So I have 54 plus a -24, which gives me 30. And then, if you're really paying close attention, what you're going to realize is that this whole triangle here is the same as this triangle here. So this is plus 48, plus 54, minus 54, 0. So let's try to get those. So I have 1, 2, 3, 4, 5, 6. So I'll call this, I just need it to be, greater than 54. So I'm going to make it 60. So 60, 50, 40, 30, 20, and 10. So first point is 0, 0. Second point is 130, 248, 354, and then 48, 30, and 0. And this makes sense because we know it has to be a parabola. There we go. So let's fill these in. So what was the initial velocity? It says the initial velocity was 36 meters per second. The final velocity is -36 meters per second. Well, what's the acceleration? The acceleration is the slope of this. Let's take the slope. All right, we'll go from end to end here, right? So we'll say -36 minus 36, final minus initial, divided by how many seconds? 6 minus 0. So this is -72 divided by 6, -12, and that's meters per second per second. So this is -12 meters per second per second. And let's see if that makes sense to us. Does it change by -12 each time? It totally does. So for every additional second, the velocity changes by -12 meters per second. This is -12 meters per second per second. The time is 6 seconds. Now, let's do this one. What's the total change in the position? Well, it starts at 0 and ends at 0, so the total change in position is 0 meters. But how far did it go? If you think about this as the position axis, it went out to 54 and then came back to 0. So it went 54 out and 54 back for a total of 108 meters. Hopefully that clears up how to do that.